let's just move on further towards the another interesting topic, which is nothing but the applications of the HCF, and HCF stands for the highest common factor. As we know that we have already done the questions that are related with the HCF involving the Euclid's division algorithm. Now using the same concept, we will do the questions that are related with the applications of the highest common factor. So let's just see the question number 1. The question number 1 says that an army contingent of 616 members is to march behind an army band of 32 members in a parade. So they have to march behind an army band of 32 members in a particular parade. The two groups are to march in the same number of the columns. So what is the maximum number of the columns in which they can march? So the question just asks you the question that what is the maximum number of the columns in which they can march behind an army band of 32 members in a parade. So let's just start the solution set of this particular question using the Euclid's division algorithm. So let us suppose we are talking about finding out. Let us suppose we have to find out the maximum numbers of the column in which they can march. So it means that we have to find the HCF of the two numbers, which is nothing but the total of 616 members of the army contingent and an army band of 32 members in a parade. So the maximum number of columns in which they can march is actually finding out the HCF in between the two numbers, that is 616 and the 32 members of the army band. So let's just start finding out the HCF of these two numbers using the Euclid's division algorithm. So let us suppose I'm writing it over here that by Euclid's division algorithm, we know that if we are finding out the HCF of these two numbers, then the very first step should be like, let us suppose by Euclid's division algorithm, we know that 616 is actually greater than 32. So 32 will be the divisor and 616 is nothing but the dividend. So let's just divide these two numbers all together. So we have 32 as a divisor and 616 as a dividend. So let's just start dividing these two numbers by taking 2 first. So 32 into 1 is nothing but 32. So after subtracting these two numbers, we are actually getting 11 minus of 2 is nothing but 9 and 5 will be here. So 5 minus 3 is nothing but 2. So we are taking 6 from above. So after multiplying 32 with the 9, so the answer will be like 32 into 9 is nothing but 18, 27 and 1 is 28. So it is nothing but 288. So 32 into 9 is nothing but 288. So we are getting a remainder as nothing but 8 only. So this is nothing but a remainder, and we obviously know that the remainder is 8. It means that it is not is equal to 0. So we have to apply the Euclid's division algorithm again on the divisor and on the remainder. So let us suppose I'm writing the very first step over here as 616 is nothing but is equal to 32 into 19 plus remainder, which is nothing but 8. So apply the Euclid's division algorithm again on 8 and 32, on 8 and on 32. So let us suppose 32 and 8 we are taking, obviously 32 is greater than 8. So let's just divide both of these numbers, and we know that we are getting 8 into 4 as nothing but 32. So the remainder is nothing but 0. So we are done over here. Our answer is over here. So let us suppose I'm writing it as 32, which is nothing but is equal to 8 into 4 plus of 0. We know that the remainder is 0. And whenever in the Euclid's division algorithm remainder is 0, then the last value b, or we can say that the last divisor should be the HCF of the two numbers, that is 616 and 32. So here 8 is nothing but the HCF of the two numbers 616 and 32. So this 8 is nothing but the HCF of the two numbers, which is 616 and 32, which is equal to 8. It means that the maximum number of the columns, the maximum number of columns in which they can march, is actually nothing but 8. So there will be 8 number of columns in which they can march. So this is nothing but the answer of this particular question. So I hope the very first question related with the applications of the HCF is all clear to you. So let's just move on further towards the next question.